Hi guys, today we're going to learn a third tactic about this molarity stuff. We're going to use gases, and what we're going to find is it's really no different than anything that we've done before. It's just a question of how we're going to get from our real world ideas out here. So these are the things that we can measure in the real world in order to get to our mole world there. So our first video, we learned all about how to get from grams to moles. In our second video, we learned how to get from solutions to moles. Now all we're going to do is we're going to get from gases to moles. So whether you're talking about the oxygen that's coming off of a plant that is producing it, or the waste gases that are coming off of a smokestack, or you're talking about pressurized gases in those tanks that you see, we know how to get moles because we know our equation is PV equals nRT, or N is going to be equal to PV over RT, assuming that we want that, right? I shouldn't have to go through this equation. We've done a bunch of experiments with this already. So, question 1 says, how many grams of nitrogen trichloride can be made if you have 38 liters at 800 millimeters of mercury and 75 degrees Celsius? So please note that all I'm doing is giving you real world data here, and you should then be able to plug all of that into PV equals nRT to get to the mole world down here. So remember that 75 degrees Celsius is no good. You've got to change that to 348 Kelvin. So you change that to 348 Kelvin and you end up with about 1.4 moles over here. Now you want to get across town. You get across town by paying our mole tax here, by figuring out what the ratio is. And it's a 2-to-1 ratio. And so that's going to be about 2.8 moles that are there. And now you want to get back out of town and you want grams. But all you have to do now is use the very first thing that we learned, which is how to get from grams to moles here. Because now I have moles and I just want grams, boom, I can just use that avenue. So you don't have to use the same avenue on both sides of the mole map. Nitrogen trichloride weighs about 120.5 grams per mole. And so now when you want to get out of it here, you just multiply those guys together and you end up with about 337 grams or so of that guy. So this is just using the idea of the gas laws for one or more of your mole map moves, so to speak. All right, so this guy here says that I want to know how many liters of hydrogen sulfide gas that's here. So how many liters of that? And it's being collected at 4.5 atmospheres and 50 degrees Celsius. So I'm going to go ahead and just change that straight to 323 Kelvin. So I want to know how many liters there are needed to produce 440 grams of that stuff there. So I've got the grams of the sulfur, so all I have to do is change it into moles. It's 32.1 grams per mole, which is going to get me about 13.7 moles of this stuff. Now what I want to do is I want to go across town. And by going across town, I'm going to pay that mole tax here, and it's going to be a 2-to-1 ratio, because again, I'm starting here at the 1 and working my way over to the 2. So that's going to end up being about 27.4 moles here. And so now I know moles, I know atmospheres, I know Kelvin, so I can use PV equals nRT, and I can solve for the volume. The volume is going to be equal to nRT over P. Plug everything in and you should be able to solve it. And if I've got my numbers right, it ends up being about 162 liters of that. Number 3, one more. It says, how many liters of hydrogen will be produced if you have 92 milliliters of 3 molar hydrochloric acid? Oh, so this is just now combining everything that we did before. This is now doing a solution to get to moles, right? So this is doing a solution. And then you're going to go across town, and then once you're across town, you're going to come back out of the moles by using the PV equals nRT. So again, nothing different here. we're just combining everything together. So we're going to start with some real world unit. And let's see, I've got 92 milliliters of 3 molar hydrochloric acid, and I want to end up here with liters of gas there. So I'm going to have to use my equation that molarity is equal to moles per liter in order to get down to the mole world down here. And so that is going to be about 0.276 moles once you change your 92 milliliters into 0.092 liters, right? So you put all that together, and then you got to go across town. So again, you're starting here at a 2, and you want to get over here to a 1. So you're going to go by a half there. So a 1 divided by 2. So that's going to get you about that's going to get you about 0.138 moles here. And now that I know the moles that are there, it told me it was at STP. So 2 different ways I can do this. If I remember that it's at STP, I can just remember the cheat way, which is that it's 22.4 liters is the same thing as a mole if you're talking about STP. So you multiply those guys together and you get 3.09 liters. Now, if you don't remember that it's 22.4 liters, then you're going to have to remember that you're talking about 1 atmosphere, and you're talking about 273 Kelvin. And now if you do liters is equal to, or volume I should say, volume is equal to nRT over P, right? And plug in your moles, your pressure, and your temperature into that, you will end up with the same answer there of about 3.09 liters, assuming I've done my math correctly.